Hi class, this is our ninth online lesson in statistics and our second for discrete random variable and the last for discrete random variable. In the first video, we studied to find probability distribution function and cumulative distribution function. In this one, we'll study how to find the expected value and the variance. See, expected value or the value which is expected to happen is generally the mean. The center value, the mean is what is expected. So expected value is also the mean. It is denoted by E of x, expected value. Okay, you can read this. Pause the video and read. The formula is to find the expected value. You just take the total of, you just multiply the outcome x with the probability. So we just multiply the outcome with the probability. This is how you get expectation of x. To find variance, we studied in the class that rule for variance. It is the mean of the square minus the square of the mean. So same mean. So for variance, you need to find expectation of x square also, which is nothing but the outcome square, the outcome square x square times the probability. Okay, in the next video, we'll take these formulas with examples so you understand better. Let's go ahead. Okay, so the formulas are written here. So this is the probability distribution table for us. Probability distribution is drawn here. These are all the outcomes x and these are the probabilities. So the first question says find the expected value or find the mean. The rule is you take the total of or add the product of x with probability. So we just multiply -1 with 1 by 5 plus, because there is a sum in this formula, total, plus 0 times 1 by 5 plus 1 times this plus 2. So we just multiply the x with the probability and add. That is what will give you expectation of x. And let me connect this, correlate this with our normal mean formula. See, we studied mean is summation of fx over summation of f. This is the same thing. When we say probability is 1 by 5, we are saying that there's a chance of happening 1 out of the total 5. In frequency, when you're finding mean with frequency, you do summation fx divide by summation of f. So you're dividing by total. In probability, we have already divided it by the total. So it's 1 out of total outcome 5. You have already divided it by the total. So it is same. It is summation of fx divided by summation of f. But because probability itself is divided, we just do probability times x. So it's the same formula, summation of fx divided by x, summation of f, but written in a probability form. I hope it is clear. It's the same thing, but in terms of probability, the formula will become like this. So let's take the the working of this. Okay. There's an alternate method here. See, one method is you just multiply what I just said. You multiply this by this. -1 into 1 by 5 plus 0 into this plus 1 by 5 into this. They took 1 by 5 common, and that is how the mean will be 1. Also, see if the probability is symmetric. Although this is uniform, this is called uniform distribution when all the probabilities are same. But apart from being uniform or same, they're also symmetric. Symmetric means the first probability is same as the last one, the second is same as the second last, and this is the center. So this is symmetric. When a probability distribution has probability symmetric, okay, then the mean is just the mean of, to find the expected value, you just find the mean of the data. That's it. So it is this plus this plus this plus 2 plus 3 divided by 5. You do that, or just center value because they are all equally spaced, or you add them, divide by 5, you get the mean. Okay, now to find variance, first of all, in the variance formula you have expectation of x square minus expectation of x the whole square. So we need this first. So what you do, you square this, multiply by 1 by 5. So 1 times 1 by 5 plus 0 square is still 0, plus 1 square is 1 times 1 by 5 plus 4 times 1 by 5 plus 9 times 1 by 5. If you just take 1 by 5 common and all of this, you get expectation of x square is 3. Now put in this formula. So it is expectation of x square minus the square of the mean, which is 3 square minus square of this one, this, and the variance becomes 2. Okay, and the standard deviation will be square root of 2 if they ask. Okay, let's take another example. A fair coin is flipped repeatedly until a head appears, or 3 flips have been made. So until you get a head, so there are only 2 ways of stopping. You get a head, you stop, or you keep doing it until you finish 3 tries. Okay, 3 times you flip the coin, and now the answer is given. You have to show that. Okay, I would like you to pause the video, try to think about all the possibilities of this experiment, and then you look at this working out. Okay, now see, one possibility is you flip the coin and it came out to be head, and you stop because when head appears you stop. Second chance is the first one was tail, the second one is head. You stop now because you got a head. The third, again, like in the previous video, we did a similar question there. It whether head comes or three tries, not till three tries, what appears, a head appears, or three flips are made. So it could be TTT or TTH in both the case. Here three tries, here also three with a H. So there are two possibility of getting this. That's why okay, so getting a head is 1 by 2, getting a tail and then a head is 1 by 2 time 1 by 2 for tail and 1 by 2 for head, so half times half, and this is half times half times half plus half times half times half, which is there are two, there are two combinations or two ways of, that's why we multiply by 2, and hence you proved. And now find the expected and variance. It's same thing, you do this into this, so on, to find mean, variance, which is done here. You multiply the outcome with probability, you got mean. Do the same thing, first do for variance, first find expectation of x square, you square the outcome, multiply by the probability, square the outcome, multiply by probability, keep adding, you get expectation of x square, and put in this formula, and this is the variance. Let's go ahead. Okay, the random variable x has a probability distribution given by, so there's a table given to us where a and b are constant to be found. Okay, first of all, even just by looking at it, see, this is a symmetric data, this probability is equal to this. So because it is symmetry, you don't need to find the mean or the expected value, you don't need to multiply them and add. It is just the mean of 1 plus 2 plus 3 divided by 3. Hence you can say mean is 2. See, the expectation value is 2, the expected value. Write down an expression of e of x in terms of a and b, and now you can write the same thing, 1 into a plus 2 into b plus 3 into a, and that will be equal to 2. And then form another equation for this. You will have two equations with two unknowns, solve them simultaneously, you get the answer. Try to do it on your own. Next. Okay, now that's it, we're done with expectation and variance. Now we go to coding like we did in other topics, mean, standard deviation and all. Okay, the expectation, when you have a linear expression inside where x is a function, a and b are constant, the coding for e can be just written as, you take the constant outside, so e expectation of x plus b. If both x and y are function, you can just separate them, so it is expectation of x plus expectation of y. In variance, we studied in standard deviation and variance, the first topic, the addition and subtraction don't affect the standard deviation, correct, or the variance, so it is only affected by this multiplication factor. And because it is variance and not standard deviation, you will square, that's why this b has no effect on coding. So variance, you just square a and multiply by variance of x. So variance of ax plus b is nothing but a square variance of x. That's it. Let us take some example now. This is exercise 6e in your textbook. The random variable x has expectation given to us, and expectation of x square is also given to us. Find expectation of 2x. You just take 2 outside, so it will be 2 times 3, 6. Let us see the working out here. So first one is just 2 times expectation of x, which is 6. The second one, both 3 and 4 are constant, so you can take them outside. 3 will become a normal number, minus 4 times expectation, substitute the value, you get the answer. This, both are function, so you use this formula now, so it will become expectation of x square. 4 is a constant, can be taken outside, so expectation of x square minus 4 expectation of 4 outside, expectation x square minus 4 expectation of x, substitute the value, get the answer. Variance, we know the formula for variance, substitute in the formula, you get the answer. For variance of 3x plus 2, you just multiply 9 times the variance, and 2 has nothing to do with the coding, so that's it. It's 9 times the variance, which is 1, and you'll get the answer. There's something wrong here. It's 9 times 1 basically, which is 9. Next. Okay, 2 tetrahedral dice are rolled. We have done this in probability. Okay, this is the sample space of throwing 2 dice, tetrahedral, 4-sided, that's why you will see only one dice, 1, 2, 3, 4, dice 2, outcomes are 1, 2, 3, 4. Okay, now x is a variable here that represents the result of subtracting the smaller score from the bigger. So it's like this, 1 minus 1 will give you 0, 3 minus 2 will give you 1, and so on. So x is what you get after subtracting. Now obviously the number at the most can be 4. So there's a combination of 4, 4 at the max, at the most, and the combination of 1, 1. When I subtract 4 minus 4, I can get 0. So there's one possibility of getting a 0. Another possibility of getting 1, which is 4 minus 3, 3 minus 2, 2 minus 1, something like that. Then another possibility of getting a 2 is 4 minus 2, 3 minus 1, and so on. And there is a possibility of getting 3, which could be 4 minus 1, and so on. So, and let us see the probability. So this is the probability distribution table. These are the outcomes for the difference. Let us see how many possibilities are there of getting a 0 as the difference. You see, 4 minus 4 will give you 0, 3 minus 3 will give you 0. These are 4 possibility of getting a 0 from the total of 16. That's why 4 by 16. Getting a 1, let us check that. 4 minus 3 is 1, 3 minus 2 is 1. So there are 6 possibilities of getting a 1. You can pause your video and try to do the remaining 2 on your own, and then you can see. Let's go ahead. Okay, getting 2. There are 4 possibilities underlined here. And the remaining, there are only 2 left. So that remaining is probability of getting a 3. So now we have a complete probability distribution with us. If the question says find Ex, Vx, there's nothing new. You just multiply and add, you'll get Ex, and same way you can find variance also. So Ex, you just multiply the outcome with probability, outcome with probability. For variance, you first find Ex squared, then put in the formula, and this is how you can find the variance. This is for part A of this question. For part B and C involves coding. Let us take in the new slide. Okay, the next part of the question says the random variable y and z are defined as y is 2 power x and z is linear, but this is not linear. So for this, what you do is you draw another distribution table, like here, the probability distribution table for y. Y is nothing but 2 power x, correct? These are all the x we have. So now 2 power x, y is 2 power 0. What is 2 power 0? 1. 2 power x here is 1. So 2 power, I wrote it here again also. See, x is 0. So 2 power 0 will give you 1. 2 power 1 will give you 2. 2 power 2 will give you 4. And so this is how you get the outcome for y. Probabilities we know. We just simplify this, written in simplified form. And to find the expectation of y, you just do this times probability, this times probability. And when you do, you get 3. However, for z, we can use the formula for coding because I see this is linear. Okay, if I just simplify this, see, I've done it here. This is 2x plus 0.5. So I can say expectation of z will be 2 times expectation of x plus 0.5. X becomes expectation of x, z becomes expectation of z. Substitute. This is also 3, this is also 3, and this is what the question is asking us to find. Show that the expectation of both are same. We just proved that this is also 3, this is also 3. Find the variance of z. See, if I know expectation, if I know the variance of x, I can find variance of z will be, this is the formula for z. The addition and subtraction has no meaning in coding. It's only this 2 square, which will become 4 times variance of x, and we just substitute, we get the answer. Let's take the next one. Okay, the discrete random variable x has a probability distribution. So they gave us a probability distribution. There are 2 unknowns. The random variable y is defined by this formula. Given that it's the same thing, and you rearrange. Although the working is here, but I would like you to pause your video here. Try to do this question on your own, and then you can see the solution. I'll just show you. So pause the video and then check your solution. Okay, so these are all the working out. It's the same thing what we did before. You should be able to do it on your own. Okay, just simultaneous equation. Next. Okay, so the simultaneous equation, and you found a and b. Check your working. Let us go to the next question. Now the next concept, or the last concept in this topic, is discrete uniform distribution. See, uniform is when all the probabilities are same. Earlier we studied about symmetric. Symmetric need not be same. The first should be equal to the last, second last, and so on. But in uniform, all probability should be same. When your distribution is uniform, then you don't have to use that big formula to find expectation and variance. There's a simple formula. But this can only be applied for uniform. First, point number 1, it should be uniform. All probability should be same. Secondly, the distribution, the outcome should start from 1. And it should go as 1, 2, 3, 4, 5, 6, like that. Not even 1, 3, 5. not 1 7 19 something like that. It should be 1 2 3, not even 2 4 6, not even 10 11 12 13. It has to start from 1. If your outcomes are not starting from 1 and going like this with a gap of 1 1 2 3, then you have to use coding to make it like this and then use this simple rule. So in discrete uniform distribution, the expectation is just n plus 1, where n is the number of outcome. In this case it is 6, so it will be 6 plus 1 7 divided by 2, which is 3.5. So the mean of this is 3.5. The variance is 6 plus 1 7, 6 minus 1 5. So 7 times 5 35 divided by 12 will be the variance of this table. So no need of finding e of x and e of x square to find variance. Okay, let's take example. Okay, the question again, I wrote the formula here for reference. 7 similar balls are placed in a bag. Okay, number from 1 to 7. So it is already 1 to 7. And because they are similar, okay, all the probabilities of getting the outcome will be same. Each one will be 1 by 7, 1 by 7, 1 by 7. So it is discrete uniform distribution. You don't need to do anything, no need of any table. N is 7 here, so 7 plus 1 is 8 divided by 2 will give you the mean. Again the same thing came. So n is 7, mean is 4, variance will be 7 plus 1 is 8, 7 minus 1 is 6, so 8 times 6 divided by 12, and that will give you variance. Let us go ahead. Now see that the outcomes are not 1 2 3 4, it is 2 4 6. Again, can you think, pause the video and think what you can do to make it 1 2 3 4. Yes, we can use coding. I can just divide x by 2. I can say let y be x divided by 2, and now my y will become 1 2 3 4 5 6. So let y be x by 2. I can use coding, so the distribution of y will become 1 2 3 4 5 6. I can first find expectation and variance of y and then use the coding formula to find expectation and variance of x. However, the first part of the question is just to find the probability of x greater than 15. In this example, greater than 15 will be 16, 18 and 20, which is 3. So 3 by 10 is the answer. Correct. And this is simple. We know n is 10. Use ey. Okay. And in place of y, write the formula first. This is how. So first you find e of y. Replace y by the formula. And then this is half e of x. Use the coding formula. So e of x will be cross multiply. 5.5 times 2 will give 11. Same, first find variance of y. In place of y, write the formula for y. You take half square, because it is variance, it will be squared. And that's it. Next. Okay, this is where I will stop. I would like you to read this question, do this on your own. That's it. We are done with discrete random variable. All the best.